Hello and welcome to the relearning for transformations for reflection, rotation, and translation. We have in here three examples of what's called rigid transformations. These mean that all figures are going to have the same shape and size. We know that as congruent. So all the shapes are going to be at the same shape and size. There is a fourth one that we're not going to discuss at this time. We're going to pick it up at a different time. But the three rigid transformations are the ones that we're going to be talking today. Their names are translate, reflect, and rotate. Now you should be writing these down on the paper that you're seeing right here. The translate, we're going to talk about, there's two things we can do. We're going to actually do the translations or the reflections or the rotations, and then we're going to write what's called the rule of transformations. There's two ways to go about it. So this one right here tells us that we're going to translate, and it gives us some instructions. We're 5 units to the right, that's this way. We're going to go this way when we move our points, and we're going to do 1 unit up, which means that we're going to go up on our y-axis. So let's just do that right now. So we're going to go 5 units. We're going to take this point G and we're going to do 5 units to the right. 1, 2, 3, 4, 5. Now but it's not finished. We have to go up one more. So we're going to put G, and G prime goes there. G prime goes there. We're going to do the same thing for our T. We're going to go over 5 to the right. 1, 2, 3, 4, 5. But this isn't done yet. We still have to go 1 up in our y-axis. We'll go up 1. So we go to the right, 5, and then this go up 1. So here is, and then we mark it because it's the same but yet not quite, we mark it as T prime. We do the same thing here, 1, 2, 3, 4, 5, and up 1 and B prime. And there is our new figure that we have in here. It's exactly the same as the one that we have right here. The G is to the left of the T, the B is on the bottom, and we're just sliding that figure up and over. So that's all that we have to do with our translate, is we follow the complete instructions that they have for each of the values. Now we take our original coordinates for our x and our y, and we're going to translate them. That means we need to do something to them to move. So when we moved to the right, we took that point right here and we added 5 sections. We're going to put that right up here, x plus 5. So we go to the right, we add. So if we take this is, let's see, what is this? 1, 2, 3, this is -3, and we ended up at +2. We went from -3, and then we added 5, and that gave us our -2, our new x value for our G problem. When we did this, we went up on our y-axis, we went up. So we took at the y and then we added 1 to that. So this is all we're doing for writing for the translating. We're sliding it by taking each coordinate for the x value and we're adding 5 to it, and each y we're giving to the adding 1 to it, and we did that to the G, the T, and the B, and we rewrote them with G prime, T prime, and B prime. Now down here is our second one that we talked about, our reflection. And the reflection tells us that we're going to flip. That's called, another way to think about this is flip. Translate is slide, and reflect is flip. So we're going to take this value and we're going to flip it over to the other side. Flip it right over to the other side. So we're going to need to know what we're flipping over. And right now it tells us that we're flipping over the y-axis. So this is our axis of reflection, our line of reflection. We're going to change this. So we're going to have each point be equal distance from our line of reflection. So we have our n here, and it's 2 units away from our line of reflection. So we're going to do 2 units over here, and this is n prime. Notice our M is right on our line of reflection, so it just stays there. It's not any units away, so therefore it doesn't move. Our O is 1, 2, 3, 4, 5, 6, 7 units away from our y-axis. So we go 1, 2, 3, 4, 5, 6, 7 units. That is our O, but it's not the same O, it's our changed O, so we put our prime notation. The last one we have in here is our R, 1, 2, 3, 4, 5 units away from our line of reflection, which is our y-axis right here, our y-axis. So we go 1, 2, 3, 4, 5 right here. Now notice our figure is what we said way up here at the top. All figures are going to have the same shape and size. They're going to be congruent. All they're doing is moving them. So if your figure turns out to be a different size and a shape, you need to check and see what your answer is in order to fix it. Sorry, little dusty in here today. All right, so we're going to look at here. So we don't always have the y-axis or right here the x-axis. Right here we have x equals 1. And this always gets people a little upset or a little confused, but I'm going to tell you that the x equals 1 is a vertical line, and it goes through x equals 1. It goes through x equals 1. So when it does that, we are using this as our line of reflection. So we're taking out, this is the only line that we have going through here. Every point on here has an x value of -1. So the whole line is called x equals -1. And if you're having trouble with that, you're going to have to memorize it. So we're going to take our same figure that we have here. We have an M here, and now it's 1 unit away. So our M is going to be right here, and that's our new M prime. 2, 1, 2, 3 units away now from our x equals 0. And so our n is going to be 1, 2, 3 units away as well. Our O, we'll do our R first. 1, 2, 3, 4, 5, 6 units away from our line of reflection at x equals -1. So we're going to do the same thing. 1, 2, 3, 4, 5, 6, and our R prime. For O, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Oh, we're off our graph. 7 and 8. We'll just put it right over here and make sure that we make it look like the same size and shape in here. Now, an x equals -1 is vertical. X equals a number is vertical. Y equals a number is horizontal. It goes this way. So you're going to have to know this to be successful at this standard. The x-axis is listed for us right here. It's already drawn in, and the y is vertical. But for our y equals a number and our x equals a number, these are vertical and horizontal. X equals a number is a vertical up and down, and y equals a number is horizontal. Okay, so now we're looking at the rules of rotations that we have in here. So there's lots of rules that we can in here. We're going to be looking at the rotation one because that's a little bit more complicated than the other ones. Over here, we have the rules in here, and we can look at the problem and we can figure it out quite easily when we're looking at these different problems on this page. But for here, we're going to have some specific ways that we need to do the rotation. So we talk about relearning for the transformations is whenever we use prime notation, we have two words that we use, pre-image, and the other one is image. So this is an image that we're going to create. So we start with the pre-image, that's the beginning, and then we go to image. So this tells us that we're going to rotate 90 degrees. So we know that is a right angle. We know that we're going to be rotating a right angle, and we're going to be going in this direction. So if we take our coordinate, and then we call this one number 1, because that's the first quadrant, And we take this as number 2 as the second quadrant, and this one is number 3 and number 4. If we go counterclockwise, we are going from 1 to 2. This is a positive rotation. A positive rotation. So we're going in a counterclockwise direction. And there's a simple rule that we use to be able to solve this. So I'm going to write my points in here, A, B, and C. Just the ones that we have up here is our pre-image. And -3, -2. And the way it works is if you're going from here to first quadrant to second quadrant. We did this in class where we investigated it, but I'm going to tell you it here is that we are going to take the X and the Y and we're going to exchange them. They're going to change places. And then the first one becomes negative or becomes the opposite sign of what it is. That's probably a better way to say it. So this is a positive 6, so this becomes a negative 6. We're going to do the same thing here. We're going to flip them. And when we do that, our 0 stays 0 because it's neither positive nor negative. And then we're going to take our C, and that's -2, -3. We exchange places, and then we make that a positive 2. So this is now A prime, B prime, and C prime. And if we were to graph that, which we're going to do in just a minute, you're going to see that it goes from one quadrant to the other. It just moves that quadrant and it creates a 90-degree angle with our vertex as the origin. So now we're going to look at 180. 180. Now we want to move not just one quadrant, but we want to move 2. So it should end up on the opposite side from our section that we have right here. So if we end up at, we start in 1 and our points are in 1, then it's going to end up over here in 3, but it does a specific way. When it does this, it takes, and when we investigated before, we found how the numbers end up when we talk about this angle measurement. But the nuts and bolts on how to do this are that this is 290 degrees counterclockwise rotation. 290 degrees counterclockwise rotations. So when we do that, we've already done one right here. So we're going to take those answers, -6, 5, 0, -4, and 2, -3. So this is one rotation, 90 degrees, and then we're putting it down here, and we're going to do the same process again, where we're going to have two 90-degree rotations. So this is going to be 5, -6, same process. You exchange the numbers, make the first one the opposite sign. So we have -4, 0, exchange the sign, -3, 2, exchange the sign, and then this becomes, if this were our A right here, we would rotate it once, rotate it twice, and then this would become our A prime, B prime, and C prime. Now, I've seen people when they've done this, they've graphed both rotations. If it asks for an 80-degree rotation, you only put the answer, even though you on paper change it twice. So this is the one we would graph. So let's take a look at our original point, 5, 6, 5, 6. So that means that would be up here in this quadrant, right? Positive 5, 6. So we're rotating it here and then here. That makes sense to us that the -5 and -6 should be the same. So this will be -5, -6. So if we start in 1, we're going to go 2 quadrants, and that's going to end up down here for our rotation. 270 degrees counterclockwise. This is 3 90 degrees counterclockwise rotations. 3 of them. So we've done one here. We've done our second one here. We're going to take those points right here. And we're going to write those in here. So this is our, we were doing our work. We would show on our paper that this is our original. Here's our first time for 90 degrees using that. Here's our second time for 180 now. using that answer, and then we would go in here and we would do the exact same thing, -6, -5, only we would change the sign on the first one. 0, 4, they don't change. 0 doesn't have a positive or negative. So we have 2, 3, we make that a -2. And now this becomes our A prime, B prime, and C prime. So if the directions asked for a 270-degree rotation, you would have to do this rotation, and then this rotation, and then this one, and then you would graph only this one at the bottom, only this one right here. Now, interestingly enough, we have 4 quadrants. So if we were to look at that 5, 6, we started here, we rotated at 90 degrees here, 180 here, and now it ends up over here in this quadrant. When we do clockwise, we go clockwise, and that means we go backwards from like 1 to quadrant 4. When we do that, we are doing the same thing as 270 degrees counterclockwise around the origin. So these two things are exactly the same. So we're memorizing one rule and we're using it multiple times. We could memorize each rule individually if you wish. They're on the internet and you can look them up. However, if you memorize this one rule and use it over and over again, you'll get where you need to go. So let's take a look at how this looks. So we're looking at this figure and it is 90 degrees counterclockwise, 90 degrees counterclockwise. Okay, about the origin, which means that our vertex where we measure each of the angles is going to be from our section. So if this is our original and we're doing 90 degrees, our A should end up over here, our B should end up over here, and our C should end up in this quadrant. So let's take a look at the original points. We have A, B, and C. A is 3, 7. C is 8, 5. B is 8, 5. And C is 9, -3. So we're going to go counterclockwise. So we're going to practice our rule and we're going to go directly what we need to do. So we take A, 3, 7. We're going to do A prime is 7, 3. And then we're going to take the opposite sign of our first one. And B prime is 5, 8, taking the opposite sign of 5, and we have C prime is -3, 9, making that the opposite sign of 3, which is, or -3, which is 3. So let's graph this new figure here on here. So we have A is, these are little numbers, 1, 2, A is -7. We go to -7 and we go up 3. 1, 2, 3. So that is our new A. And our B is -5. And then we go up 8. So this is right here, B prime. Now, our figure at the end of the day should be exactly the same size and shape. It should be just moved. And C is 3, 9, which puts us right, this is 7, 8, 9, B prime. So when we measure this out, put this together, we should have exactly the same shape as we did here, but you can see it move from here to here. It's a 90-degree rotation. If I were to take this here and measure the angle from A to A prime, I would see that that is a 90 degrees, and it's the same for each one. B to B prime, C to C prime always creates a 90-degree rotation. Okay, so we're looking down here. We have the same figure, just like what we did up ahead. And we're going to rotate this 180 degrees. So we already did 90 degrees up here. So I'm going to take those values, -7, 3, and -5, 8, and 3, 9. So we've rotated it 90 degrees here, and now we're going to take the same figure and we're going to rotate it again. So this is going to be our new A prime. It's going to be 3, -7, making the opposite sign of the 3. Let's see, 8, -5, making that -8. And then we have 9, 3, making that a -9. So looking at this over here, we're going to go -3 and then down to -7. Yeah, that looks right. So that's A prime. And then B is -8. B, -8. Right here. 1, 2, 3, 4, 5 is B prime. And then C is going to be -9. 1, 2, 3 is C prime. And there's our figure, and they're directly across. So if we were to measure this from the C to C prime, we see that we have a straight line, which is a 180-degree angle. So that's rotation. Every line should be directly away from here, with our directly as a straight line with our vertex as the origin. Okay, over here, we're going to look at the rules of the other ones in here and how you can tell the difference, So when I give you the two figures, you can see on here that this is Z prime and this is Z. If you're not 100% sure when I give you the assessment, you can put one on here so that I can see what you're thinking about. Now you're thinking to yourself, oh, we just did all this work on rotation. Shouldn't this be rotation? Well, let's take a look at our angles. So when we look at this right here, I'm going to do this with my pencil so that you can see that this right here, if we go down to our vertex, there's an angle right here. Ooh, it's not very 90-degree like. That should send off a red flag to us. Let's look at this one right here. Even skinnier, they're not the same. They're not the same. So it cannot be a rotation. So it can't be a rotation. So it has to be one of the other ones. It has to be either translation, where we're sliding it around, or it's reflection. Clearly, it's not reflection because the poles are on the same side. So this here is, if it were reflection, the pole would be way over here. It would be like flipping and putting two books together, like what we talked about in class, two books. So this is translate. And the rules should work for each point. So let's take a look. We're looking at X and Y. We're going to take a look. We're going from Z. So the X tells us that we're going to go to the right. 1, 2. We're adding 2. And we're going down 1. So we're going to subtract 1. So does this work for each one? 2 to the right and down. Yes, it does. 2 to the right and down. Yes, the rules should work for each and every point. Looking at this one right here, oh, it looks very clearly like it's turning. And so it's going from this way though. This is our X, and then here is our X prime. So our Z looks like it's turning, and if we were to make angles on here, we would see that the angles are all the same. So I'm going to use the Y in here to look at the degree that we're actually turning around. Yep, 90 degrees. So we're going from quadrant 2 to quadrant 1. That's backwards. So we're going to rotate 90 degrees clockwise. And then our vertex that we're swinging it around is around the origin. Now, if you're looking at this and you're thinking, oh my gosh, Miss, we just did all this work for the rotation counterclockwise, you can do that too. We could go this way around, right? We're going from 2 to 3 to 4. And that would be rotate, this is an or, rotate 270 degrees counterclockwise around the origin. They are exactly the same. So let's take a look at this one here. The B's are on opposite sides. The A's are on opposite sides. It's like if you were to fold your paper, you can use your imagination. They would fold the paper. This would be your reflection. This is reflection. So we're reflecting. Which one is equally in the middle of each one? Well, that would be this right here. That would be this right here. Each one, if we were to fold it, that would be our line of reflection. And the line of reflection is over the x-axis. The x-axis. Now the x-axis has a second name if you wanted to use that. That is y equals 0. Because we know, we just talked about it, that the y equals 0 is horizontal. And every y value on here is 0. Every y value on here is 0. So let's take a look at this one here. Oh, it looks like it's flipped. We have a D and a D prime. They're on other sides. If we were to slide it, we wouldn't get the same rule for each point. Doesn't look like it's rotated, although it could be, but we're looking at this, and the easiest way to do that is that this line is directly in the middle of each and every point. So we are doing a vertical line, and that is x equals, where are we at? 2. So we write reflect over x equals 2. Reflect over x equals 2. So we're just flipping that directly over x equals 2. And so it makes it nice and neat. So you have to keep in mind that you are looking at vertical. X equal a number is vertical. Y equals a number is horizontal. All right, good luck. Do the U tries. Show me the U tries on the next page. And then once we're done with that, we will get you the reassessment. Thank you.